All right, so in this video, I just have two more examples that I want to show you guys. So what if you have a cosecant? Well, for cosecant, you already know that the cosecant is just 1/sine of whatever this argument is, right? Okay, so you're probably going to be using your sine limit theorem again, but I'm going to multiply top and bottom by 4, right? Because I want to make this argument, I want to make this term right here look like this argument. And so what I'm going to do right now is move the 1/4 out, because that's a constant. And you're almost there, and once you get to this line right here, right, you're like, well, my theorem for, limits is, the limit as x approaches 0 of sine x, right? The limit as x approaches 0 of sine x over x is equal to 1. But does the limit as x approach 0 of x over sine x is equal to 1? And the short answer is yes, okay? But let's do a theta substitution here. Let's write 1/4 the limit as theta goes to 0 of theta over sine theta, right? That's basically what this problem boils down to. And you could do a couple of things, right? You could rewrite this as 1 over the limit of theta goes to 0 over theta over sine theta, or you can rewrite it like this. This is what I'm going to do. I'm just going to say this is the limit as theta goes to 0 of sine theta over theta, right? How did I flip it? I mean, this thing is the same as this, right? Okay, so, this is 1, right? 1/4 to the 1 to the -1 is just 1, and then 1/4 times 1 is just 1. Okay, so there's really nothing to it. The limit as theta over sine theta also goes to 1 as theta approaches 0, because you could just use the reciprocal, or the, it's actually called the power rule in your textbook. Okay, all right, last problem. I'm going to shift over to number 11. And this one, you basically can just rewrite it as the limit as x approaches 0 of sine squared 3x. Sine squared 3x just means sine of 3x times sine of 3x. So let's write that. Sine of 3x times the sine of 3x. And what you want to do right here in your denominator, right, is to make it such that they all have 3x's. So let's write that. 3x, 3x, right? Because that way we know this is going to turn to 1, this is going to turn to 1. And 3x times 3x is 9x, right? 9x squared. I'm still missing a 2 here, so you're missing a 1/2. And this time you don't need to multiply top and bottom by 3 over 3, right? Because you already have a 3 here, you already have a 3 here. Okay? So double check your work, right? 3x times 3x is 9x squared. 9x squared times 2 is 18x squared. So I basically split up this product into individual factors. All right, so you can move this constant out here, right? And then you can use your theta substitution. Limit as theta goes to 0 of sine of theta over theta, and times the limit as theta goes to 0 of sine of theta over theta. Okay, so I didn't write this, but theta just equals 3x. Let theta equal 3x. Okay, this goes to 1, this goes to 1. You're going to get 1/2 times 1 times 1, which is just 1/2.